Good morning. Today we're going to continue on with trigonometry, the ratios. Yesterday we focused primarily on tangent. Today we're going to really bring together all three. So again, here is just a summary of what we talked about in yesterday's video, that we have the abbreviation for sine, cosine, and tangent is SIN, COS, and TAN. And then the theta stands for any angle. It's just like a variable x. And then we also talked about a common way that you'll hear this represented to remind folks how to do it is SOHCAHTOA. So again, that's coming from the first letter of each thing. SOHCAHTOA for sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. What you see here are simply graphical representations of sine, cosine, and tangent. And you can see here in this one right here that the red line is the sine curve, the green line is the cosine curve, and the blue is the tangent curve. You won't actually begin graphing these until next year, but I want you to understand that these three functions do translate to equations, just like the other functions that you write. So again, here you have the blue is the cosine, the red is the sine, and this orange is the tangent. And as I said, you'll talk more about that next year. It's what we'll see these though, however, probably over the next few months. This we did yesterday. It's really just a reminder. I'm going to walk through this here. Is that what we did yesterday is we talked about here that when you write tangent of S, that it's the opposite leg over the adjacent leg. So you have to remember the opposite of S is that 80 and the adjacent is 18. Remember, 82 is the hypotenuse in these equations, right? So each of these two angles, S and R, only have one adjacent leg. The other side is the hypotenuse. And if you'll notice, we never do T. T is 90 degrees. That's what makes this the right triangle. So the cosine of R, here's R, our adjacent leg is 80 and the hypotenuse is 82. The other thing I want you to point out here, or that I want to point out, is that these are going out 4 decimal places. And that's what we normally do in trigonometry, is we bring it out 4 decimal places unless you're told differently. So here's some new information, and we're going to begin talking today about the angle of elevation. Now the angle of elevation here is basically if we're looking straight forward here. So if you were coming up out of the water, maybe you were swimming and you're hanging on the deck and you're looking straight forward, the angle of elevation is the angle your eyes would have to lift to see the top of the light switch here. So that's this black angle here. Right, that there is your angle of elevation. It goes up from level with the ground or up from straight ahead. So another way to think about this, you can see the lovely little boy here, and his big brother here is up on the ladder. And he would normally be looking straight ahead, but because he's looking up at his brother, you have an angle of elevation here. And just like the big brother might normally be looking straight ahead, he's looking down. So that's an angle of depression. So we're going to look at these two. This angle is the angle that the little boy is looking up, and this angle is the angle that the bigger brother is looking down. So that's the angle of depression. It goes down from straight ahead, or it's depressing his head down. And this is the angle of elevation here, because he's looking up. And what you'll notice, since these two lines are parallel, these two angles are congruent due to the alternate interior angles theorem. So let's take this example here. You're skiing on a mountain with an altitude of 1,200 meters. the angle of depression is 21 degrees. How far do you ski down the mountain? Now remember, the first thing we always want to do is draw that picture. So we have a 1,200 foot is how high the mountain is. That's the altitude. So it's straight up. It's not how long your ski run is. It's the altitude. And then it's an angle of depression is 21 degrees. So you're up here, and if you're looking straight, you would look this way, but you're looking down the mountain, right? So that's 21 degrees. That's where the angle of depression is coming from. And the question becomes, how far do you ski down the mountain? Now let's think about this. We have a hypotenuse and we have a leg here. But based on the 21 degrees, which leg do we have? Hopefully you're able to come up with the fact that it was the opposite leg. And so we have the opposite and the hypotenuse. And so we go ahead and solve the sine of 21 equals 1,200 over x. Now again, the x is in the denominator here. A lot of folks think that what we can just do, since it's division, is multiply 1,200 times 21. We cannot do that. You need to multiply by x and bring that over, and then divide by the sine of 21. So you need to end up with this setup. Then in your calculator, put in the sine of 21 degrees. Remember, we rounded to the 4th decimal place. And then we get approximately 3,348.2 feet. So that's about how far you are skiing down the mountain. Now what would happen here if we change the angle of depression to 28 degrees? What do you think? Hopefully you were able to come up with 2,556. If you're not sure, go ahead and pause it right now and calculate it on your own and see if you do indeed get the 2,556 meters. And then you have the example on the left to follow. Let's use some 30, 60, 90 triangles here just to practice finding the sine and cosine. So the first one, with example 4, we're going to use a special right triangle to find the sine and cosine of 60 degrees. So we're simply going to set it up. Here's our sine and cosine diagram we're going to work with. In other words, it's a 30-60 triangle with the ratios 1, 2, root 3. So we're going to use these to figure out sine and cosine. So first thing we need to come up with is our sine ratio, which we know is opposite over hypotenuse. So the sine of 60 degrees is the opposite, which is radical 3, over the hypotenuse, which is 2. Now think about that. If we do the cosine of 60 degrees, right, the cosine equals the adjacent over the hypotenuse. So we're going to go ahead and put in the adjacent over the hypotenuse, which is 1/2. And you can see again here, when it's a radical and we change in the calculator, we always get an estimated number, hence this is approximate, and this one's exactly 0.5. Now we're going to use the special right triangle again to find the sine and cosine of 30 degrees. I'd like you to pause this for a minute and go ahead and calculate it yourself. Hopefully you paused it for a second, and now we are going to go ahead and continue, and you should get 1/2 and 3/2. What I'd like you to point out here is that the sine of 30 degrees is 1/2. Well, that's the same as the cosine of 60. And the sine of 60 degrees is radical 3 over 2, and that is the same thing as the cosine of 30 degrees. So they are the opposite of each other. And the last one is find the sine and cosine of 45 degrees. Again, we're going to go ahead and in our heads, or if you need to draw it out, which is normally what we suggest, we'll go ahead and draw that right triangle here. We get 1 root 2. Okay, so if you go ahead and do that, the sine and the cosine here of a 45 degree angle, remember that the sine of theta equals opposite over hypotenuse. Well, that's going to be 1 over radical 2. You can't have a radical in the denominator, so you have to multiply them both by radical 2, and that's where we get radical 2 over 2, because remember this becomes radical 4, which is radical 2. The cosine of theta is adjacent over the hypotenuse, but when you go ahead and sub it in, you're going to get the adjacent is 1 over radical 2, so it's the same thing. So the cosine and the sine of 45 degrees are both radical 2 over 2. Now again, this here, I just am reminding you yet again of these equations that sine is the opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and you'll hear SOHCAHTOA to refer to it a lot, where it's sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. I'm obviously mentioning this and reviewing this numerous times. As I mentioned earlier, this is a really, really important concept that you get. So one of the things here is we're going to go through and look at these here. And we did parts of this yesterday, so I'm just going to talk through this here. The key thing is we're going to do cosine of u, sine of w, and tangent of u and w. Right? And so this is where I'm going to start with. We did go through this briefly yesterday, but I do want to point a few different things out. First of all, since v is 90 degrees, then we know that the measure of angle u plus the measure of angle w must also be 90 degrees. That tells us that these two angles are complementary angles because they sum to 90 degrees. So I want you to keep that in mind in terms of what we're about to talk through. So what I want you to notice here is if we take the cosine of u and the sine of w, remember u and w are complementary, you'll notice that they are equal to each other. So the cosine of one angle is equal to the sine of the other angle. Again, the cosine of one angle is equal to the sine of its complement. Now, here I want to look at the tangent of u and the tangent of w. Now remember, u and w are still complementary angles, but what you'll see here, and it's easiest to see this in fraction form, is that they are the reciprocals of each other. So that the tangent of one angle is the reciprocal of the tangent of its complement. So again, here, the tangent of A and tangent of B are reciprocals as long as A and B are complementary, and that always happens when we're talking about a right triangle. So given that, let's go ahead and try to do these three here. I want you to, again, pause this for a minute, try and complete all three of these. Then when you feel like you've given it a good shot, go ahead and play this and make sure that you are getting these correct. Okay, so now the first one says rewrite the cosine of 65 as the sine of x. Now remember what we said, that the cosine of 65 is equal to the sine of its complement, so we want to subtract 65 to get its complement, and so it would be the sine of 25. Second, here it says rewrite the sine of 37 as the cosine of x, so it's simply the reverse. Again, cosine of the complement is equal to the sine of 37, so we need to find what the complement is, and that gives us cosine of 53. And finally, if the tangent of 30 is 1 over radical 3, what is the tangent of 60? The first thing we need to verify is that 30 plus 60 equals 90 degrees, and it does. That tells us they're complements, which means that we know that it is the reciprocal of the tangent of 30. So since the tangent of 30 equals 1 over radical 3, then the tangent of 60 must be its reciprocal, which is radical 3. So again, what we're doing now is we're taking sine, cosine, and tangent, and we're bringing them together and applying them a slight differently. So again, you're going to use this information that we've just covered to complete your assignments today. And hopefully, again, this information was clear. And if you have any questions, please don't forget to ask.